Andrew, you are going to get them awake. How warming in the ocean impacts people through changing weather and altered ecosystems. You're working at Climate Central. We have seen you the last couple of years before. So for the most of us, you're just a famous face.
I really like to go in the ocean. I didn't get to do that here, but as you'll hear, I'm actually an oceanographer, and so getting into the water is my favorite thing.
So whenever you travel, you don't bring your bathing suit?
I usually do. This is an unusual trip. I did not have time, unfortunately, here in Nice.
You can buy them here in the boulevards.
And it's France. I probably don't even need one.
I'm not sure. It's important days in Nice. You've seen all the police here around?
Yeah.
Good luck. I'll give you the stage. Ladies
all right, thank you.
Andrew.
All right, hello. So my name is Andrew PERSHING. I'm the Chief Program Officer at Climate Central. So I'm here with my colleague Bernadette. Where's Bern? There's Bern. Hello, Bern. So at Climate Central, we do climate science and we do climate communications. And so I'm a little bit more on the science side. Bern's a little bit more on the communication side, but we both do a little bit of both. But I'm actually, as I said to Helga, I'm an oceanographer. And it's really exciting for me to get to be here in France because of this guy. Right, Jacques Cousteau, who is the best science communicator, at least he had the biggest influence on me. So his TV shows in the 70s and 80s are why I became an oceanographer. But he was doing this for a long time, even before. I'm not old enough to have been around in 1956 when Silent World came out. But when Silent World came out almost 70 years ago, this was a transformative moment. This was the point where Jacques Cousteau launches his career as a science communicator. But it's also the first time that every human being on the planet could see a coral reef in color, right? That was the big thing that he was doing with this film, was actually filming underwater in color. So an important moment. So one of the things we like to do at Climate Central is to try to think about change in the world from the point of view of people. And so I'm going to show you a little bit of change in the world from the point of view of Jacques Cousteau. So this is the, and we've seen similar graphs before, this is the amount of heat that is stored in the ocean. So the total heat content stored in the ocean, it's 25 exajoules of energy. Nobody knows what an exajoule is. So to put that in perspective, that's about 400,000 atomic bombs worth of extra energy that has gone into the ocean that has changed this, this pattern here. So Jacques Cousteau starts his career as a climate communicator, or as a science communicator, back in 1956, here at very much the low point of the record, where the ocean was storing much, much less heat than it is today. He worked throughout his life to bring the ocean to people through filmmaking, through communications, and he passed away in 1997. And so you can see over his life how little change there was. There was change in the ocean, right, in terms of the heat content, but much, much less than what we have experienced, right, even over the last 10 years. And of course, we know what's driving this. It's the concentration of carbon dioxide in the atmosphere. We are burning too much fossil fuels, coal, oil, and natural gas. That is causing all of this heat to get trapped on the planet. And as we heard earlier, right, the oceans have an important role to play. They've absorbed about 90% of the heat that we've trapped onto the planet through CO2. And while they were doing that, they were also absorbing 30% of the CO2, right? And that has helped buffer us from the worst effects of climate change. So I'm going to move now from this global perspective and start to move in and develop a bit of a local story. So this is a graphic that our team at Climate Central put together, similar to one that was shown, I believe, in a slide or two before, or a talk or two before. This is the global surface temperature record. This is from the satellite data. And so you can see here in 2025, right, that we're tracking very close to the top. We're actually a little bit down from where we were in 2024. But this tool gets updated every day, and you can download this graphic in multiple formats. You can also look at what's going on in the ocean on a daily basis, and we do that through the Climate Shift Index Ocean, csi.climatecentral.org/ocean. So this is a service that we launched last summer to look at change in the ocean. So this is the sea surface temperature anomaly from a couple of weeks ago when I had to turn in my slides. It's actually fairly similar today. I was looking it up today. But you can see it's warm in the Western Mediterranean, a little bit cooler in the Eastern Med and in the Black Sea. And the question is, how has climate change influenced those temperatures, right? We can say it's warmer, but is that warmth coming from, natural processes, or is that warmth coming from climate change? So we're going to do that through a process called climate change attribution. And we're going to imagine, what we're going to do is find the distribution of daily temperatures in today's climate, where we're at roughly 1.3 degrees of Celsius of warming since the pre-industrial period. So what we will do would be to look at the waters, let's say the waters off of Nice, and we are going to say, what is the distribution of temperatures? How frequently do warm temperatures, cool temperatures, right, cold temperatures occur for this time period in early June? This is trying to represent the recent climate. But then what we can do is use the tools of science. We use climate models, and we use the local warming trends to try to produce this distribution. We call it the counterfactual distribution. This is, in some ways you can think of this as we've been talking about digital twins. This is a digital twin of this kind of statistical view of the ocean. And so we'll look at what is the distribution of temperatures in that climate without human-caused climate change. So then what we'll do is take an observed temperature, right? Let's say the temperature today off of the coast here, and we will then look at the likelihood in our current climate. So that temperature is highly likely in our current climate, and it's much less likely in that blue climate, in that no global warming climate. And so then we can make a statement, for example, that these temperatures are roughly 3.5 times more likely because of climate change, right? Climate change made those particular temperatures 3.5 times more likely. So if we go back to our climate shift index map, so you can look at the anomaly, but then you can also look at the climate shift index, which is going to tell you those likelihood ratios. So off of Nice, we were looking at temperatures that are roughly 10 times more likely because of climate change. So a relatively significant increase in temperatures caused by climate change. The temperatures here would be hard to imagine in a world without climate change. So what are the consequences of the warming that we're seeing in the ocean? Well, I'm going to now talk about the weather side, and then I'll talk a little bit about the ecosystem side. So on the weather side, we have ocean storms, especially hurricanes, tropical cyclones, are a major connection between heat in the ocean and impacts for people on land. So in our Climate Shift Index service, you can select tropical cyclones, and you can go and look at different hurricanes in the Atlantic. Right now we just have the Atlantic, but we're going to be building that out and showing more coverage around the globe. The tool is global, but the hurricane work for right now is just for Atlantic hurricanes. So this is from September 27th last year. This is the track line of Hurricane Helene. That was a devastating hurricane that hit the United States, killed a lot of people, did a lot of damage, especially in North Carolina. And what we're able to do is go and look at the track line and say, okay, over that, on the day where it was strengthening, it went from a Category 1 to a Category 3 over the span of about 2 days, that period of rapid intensification was over water that had temperatures that were 10 to 100 times more likely because of climate change. Those water temperatures of that magnitude in the Gulf of Mexico basically could not exist without climate change. Those conditions just would not have occurred in the past. But we've started to do this for other kinds of storms, and we do this a little bit more manually, and we will release alerts every now and then, or explainers after an event. So this is for the Valencia floods last year, and what we're doing here in this diagram is saying that the storm that led to those extreme floods was pulling moisture out of a region in the tropical Atlantic, right? And so the source of moisture was driven by water temperatures that were 50 to 300 times more likely because of climate change. We did a similar kind of analysis for a storm that hit Ireland and the UK, similar 40 times to 100 times more likely because of climate change. One of the things, I'm not showing any of our air temperature stuff, but if you remember our talks from the last couple of years, our air temperature scale goes up to five times more likely. Here in the ocean, we're going up to 800 times more likely. And that just shows how significantly we've altered the conditions in the ocean. The oceans have really absorbed so much change. One of the things that we can do, though, so I've been talking about likelihood, and likelihood is it's a convenient way of talking about change, but it's not necessarily what you want all the time. Sometimes you actually want to know a temperature, and so we can use our system to back out, to postulate a temperature that would have existed in a world without climate change. All right. We might say that things were 2 degrees warmer. So we can say back in the day, 290 parts per million CO2, lots of fossil fuel burning have brought us up to 430 parts per million. Back in the day, 0 degrees of warming. Today, 1.3 degrees of global change. 30 degrees Celsius water in the Gulf of Mexico last year, and that led to a Category 4 hurricane. Research by our colleague Daniel Guilford allows us to make this leap from ocean temperature to the strength of a hurricane. 29 degrees Celsius in the counterfactual in a world without global warming would have led to only a Category 3 storm. Okay, and I say only. Category 3 is a big storm, right? That is a devastating storm. But the difference between Category 3 and Category 4 in terms of the damage is actually quite significant. So I'm going to go quickly to coral. We've heard a little bit about coral bleaching. The biology is super cool. I don't have time for it. But we can actually model the risk of coral bleaching through a function of temperature. This was developed by folks at NOAA in the US. So if we run that model with today's climate, with today's temperatures, so we're modeling the exposure of reefs around the world, this model says that there were temperatures that would have led to mortality events in many places, especially in the Caribbean, over the last several years. There's a display behind you that talks about the 4th global mass coral bleaching event, which is what we're talking about here. In our counterfactual world, no bleaching. Bleaching is entirely a phenomenon caused by humans through climate change. And if we bring this back to Jacques Cousteau, Captain Cousteau died in 1997. The first global mass coral bleaching event happened in 1998. He never saw, in all of the years of diving, he never witnessed a global mass coral bleaching event. It just was not something that existed when he was doing his work. And so we really have profoundly altered this system. So 1956, when Silent World came out, was the first year every human could see a coral reef in color. Now we are looking at maybe one more generation before coral reef ecosystems. Not corals, the animals themselves, not necessarily the fish themselves, but the functioning, vibrant reef ecosystems could be extinct in another generation. So quick summary, climate change is warming the oceans. We've heard a lot about that. We see more intense storms, wetter storms, bigger, more powerful hurricanes. There are impacts on ecosystems. I talked about bleaching coral. I could have done a similar thing, talked about fisheries. There's lots of stories in the ocean in terms of the impact of temperature on ecosystems. We can, with our systems at Climate Central, quantify the change at a daily local level. So we do that with the Climate Shift Index Ocean and the Climate Shift Index in air, if you're interested in that. So thank you very much. It's really fun to be here.
Good story. I dropped down some plastic from my phone. I'll carry it up. Thank you, Andrew. Any questions? Was it so interesting or so boring? Was it interesting?
I bummed everybody out with the coral.
Was it boring? Hands up.
Just a quick one. Did you do a study on Hurricane Otis and the rapid intensification and what the climate shift index was? I'm just curious because that was unbelievable.
No, we haven't looked specifically at Otis because was on the Pacific side, not on the Atlantic side. Yeah, but it is one that we have our eye on. It's a fascinating one. Yeah.
Yeah, it was near Acapulco, right?
Correct. Yeah, and it was the one where the forecast was really challenging.
Hold on. You don't have a mic, and people have to hear you.
Hurricane Otis, for those who don't know, it went from tropical storm to Category 5 in 24 hours, and that was 24 hours prior to landfall. They had no idea they were going to get hit by a Category 5. They thought there was a tropical storm and maybe a Category 1 that was going to come ashore.
And that's the big changes we have. Thank you.
Can you provide, so you did a fantastic talk and your work is really fantastic also for us scientists, but can you explain how you build your indexes, what are data and what is the potential loss we can face about it?
Sure, thank you. So, and before I do that, one thing on data, I forgot to mention that all of our products are available in KML format. So if your weather systems can use KML, we can serve you the maps through KML. So a question about the data. Our system is actually based on ERA 5, our air temperatures. Our ocean temperatures are based on NOAA's OISST product, so that's collected by the United States. Actually, following Hurricane Helene, our system was down for a few days because the NCEI, the U.S. Center, was in Asheville, North Carolina, that was hit by the hurricane, and so all of their data services went down. So we scrambled and made sure that we actually can use as a backup the OSTIA product, which is a European product. So we have both of those in our pipeline now. So we're OISST is our main system that we're using to do our assessments, but we can shift to a European product, and that's a redundancy that we built for the weather, and now it's a redundancy that we hope we don't have to use for other reasons.
Better be safe.
Yeah.
No politics, but.
The ocean heat content is not just SST, it's ocean data.
Correct, yeah. The ocean heat content that I showed, I got that from NOAA. There's great products here from Mercator as well, yeah.
There was another question in this corner, wasn't it? Other corner. 1, 2. And it's a wrap. Thank you very much,
Thank
Andrew.
you.
Thank you. Give him a huge applause.